Okay, we're in section 33 of the notes, and we're going to do the example. This is about the fundamental theorem of calculus. This is going to speed the process up a great deal, but my understanding is we do need to connect it with our past visualization. And as I do that, I'm going to connect some of these with our past, if it's easy. If it's difficult connection, I'm just going to use the FTC. All right, so let me go to the whiteboard. As I go to the whiteboard, we would recommend that you also have pen and paper ready to also try to follow along and take notes, of course. Give me a second. And, one problem at a time. But by that, I mean, I look at the problem. Certainly some people, my goal is to do this quickly. Your goal should be to understand, not to do things quickly, but to understand. Now, the first thing I do is I want to visualize the problem. And if I do that, I'm going to say it's fairly simple. I'm going to visualize this. We're starting at x equals 1. I'll put this over here. This is x equals 1. And we're stopping at x equals 3. So 2, 3. We're stopping over here. And what's the function? The function is actually equal to 2. So what's that going to be? Y equals 2. What's the area? This is the area. Well, I'm going to say it's a fairly trivial problem. What's that going to be? The base of it's 2, the height of it's 2. So this should be a 2 by 2. That's going to be a square. And that would equal 4 units. But they didn't say do that. They said use the FTC. Well, let's do the FTC. This is 1 to 3, 2 dx. What's the antiderivative of 2? Well, it's 2x. Now, someone's going to say 2x plus c. You can do that if you want, but the c is always going to disappear in a definite integration. And what do you get? 1 to 3. I'm using the FTC. Upper limit, so it's going to be 2 times 3, minus the lower limit, which is going to be 2 times 1. What do you get there? 6 minus 2, which is 4. Do we get the same answer? Of course we do. Let's do this one over here. And this one over here, a little more complicated. Again, we can visualize it. And someone says, if you visualize, could you get the answer? Unlikely. It's unlikely you're going to get the answer without a tremendous amount of work. I'm not saying you can't do the work. I'm just saying I don't know if it's worth doing the work. So I want to look at it. And when I'm looking at it, I just want to get an idea what happens over here. All right, so what do I get over there? It says it starts at the -1, right? So it starts at -1. And at -1, what would you get? Well, you get -1 minus 1, which is -2. And -2 cubed is going to be -8. So this thing's starting way over here. And then what happens? I start to realize that it goes up to 2. And what would I get at 2? Well, 2 minus 1 is 1, and 1 cubed is 1. So I'm going to put something over here. All right. Now, what's the y-intercept? That's when x is 0. I would get -1. And again, I'm not saying, you're looking at this thing and saying, gee, can I do that? If I do okay over here? Oh, I'm sorry, there's an x-intercept too. So I can say, I hope you realize that whatever this thing looks like, whatever it looks like, you've got troubles over here. And I'll point out what the troubles are. It's figuring out these areas over here. I hope you realize that, even my really bad picture, it's not a great picture. Let me see if I did okay with the picture. X is 1, it gets 0. If x is -1, I get -8. And if x were 2, I'd get, yeah, it looks all right. It looked great. But I hope you realize that this one over here, it definitely overpowers it. And it's a negative area here. And this is a signed area, by the way, and that's positive. So I know my answer is negative. Here comes my trouble. I don't know the number. Looking at my picture. My picture's so bad, I have no idea what the number is. Other than the fact that I know the number is negative. What I have to do, believe it or not, is since I don't know much about calculus at this point, I got to expand this. Now, where'd you learn about expanding this thing in Math 120? It's a binomial. And what are you going to get? I'll write it down for it very carefully too. So it's going to be x cubed minus 3x squared plus 3x minus 1 dx. Let's keep moving. I'm going to use the fundamental theorem of calculus and get the antiderivative. That would be x4 over 4 minus x cubed. The 3's would cancel, by the way, plus 3x squared over 2 minus x. And there would be a constant integration, but it's going to disappear in the definite integral. And the limits are going to be from -1 to 2. Let's see if we can do the arithmetic. And what is that going to give you? Well, 2 to the 4th power is 16. So 16 quarters minus 8. I'm plugging in 2, by the way. What do you get over there? 12 halves minus 2 minus, it's a lot of work though, isn't it? What do you get over there? 1 quarter plus 1. I'm plugging in minus 1 now. Plus 3 halves plus 1. All right, it's work. I got to put the work down for you though. 4 minus 8 plus 6 minus 2 minus, I think I can do this one over here. I'm going to do the 1 quarter and 3 halves. And by the way, if I make a mistake, I'll know that by looking at my key. Mistakes are going to happen when you start practicing. A quarter and three halves is going to be 7 quarters plus 2. All right, let's keep going. Let's see. 4 plus 6 is 10. Minus 8 minus 2 is minus 10. So that's 0. That's pretty good. Minus, now I got to do this. 7 quarters plus 8 quarters. What does this give me? Minus 15 quarters. It's a lot of work though, isn't it? I got an answer. By the way, if you think this is a lot of work, you should just try to do this by doing a limit with Riemann sums. You'll get the same answer, by the way. Minus 15 quarters. By the way, when I say get the same answer, if I've done it correctly. Wow, we did it right. All right, let's look at number 3. Now, I don't think I want to draw a picture of that. It's just too much work for me. So I'm not saying you can't do it. Even if I draw a picture, it's really not going to help me much. You know, I got to do the integration. As soon as these numbers are crazy. These numbers have been carefully selected to make your life easy. You may not believe that, but they have. I need to simplify the integrand. So it's 4/3. I'll write it tonight. I'll erase it later. 4/3 minus 2, and 2 is 6/3. So it's going to be x to the minus 2/3. Minus 8x. Let me do the other one. It's going to be 1/3 minus 2. That's minus 6/3, isn't it? And what's it gives me? Minus 5/3. Let me get my eraser out. Erase my baby arithmetic on the side. Let me point this out again. We'll give you an answer key for a reason. We want you to look at it, but not until you do the problem. So let me put my antiderivative down, and I'll be careful. That's going to be 10x. I have to add 1 to minus 2/3. That will be 1/3, and I divide through by 1/3. I'll do that later. Minus 8x. I have to add 1 to that exponent. That would be minus 2/3. And I have to divide by minus 2/3. Now there is a constant integration, but it's going to disappear on this definite integral. Let me write this down. I'm going to simplify. This is going to be 30 x to the 1/3. And this is going to be plus, let's take a look at that. That would be what? That would be 3 halves. That would be 4 times 3 is 12. X to the minus 2/3. Limit integration 1 and 8/27. Let me stop for a moment, see if I did okay. And again, I'm looking at that. That would give me plus 4 times 2. Yeah, look at it. Let's do this. The 1's a gift. So I get 30 plus 12 minus this lower limit. And let's see if I can put that down. It's going to be 30 times the cube root of 8/27. That's going to be 2/3. That was easy. Plus 12. I want to review what your teachers told you to do in Math 100. And what you're doing is 8/27 to the minus 2/3. And again, your teachers in Math 100 would have said to do this. Again, if you're doing it differently, that's fine. As long as you're matching my answer, that's fine. That's going to be the cube root of 27, which is 3 halves. I'm sorry, the cube root of 8 is 2. And then I got to square it, which can be what? 9/4. All right. That's my baby work on the side. I'll put this down over here. And I got to do the work. So what is this giving? 42 minus, let's be very careful. 3 goes into 30 10 times, and 10 times 2 is 20. And over here, what do I get? Well, 4 goes into 12 3 times, and 3 times 9 is 27. Again, I'm going to repeat this over and over again. Mistakes happen. That's why we give you keys. We want you to fess up to your mistakes before it's too late. This is 47. And what does this give us? 42 minus 47 is minus 5. Now, granted, if I made a mistake, I have a problem in my hand. I got to look for my error. Let's take a look. We did it right. Okay, we did it right. Let's go to the next page. And what's next page? Just nightmare over here. Again, you could draw the picture of it. And the picture of it's really not too bad. But my goal here is not to draw the picture of it. My goal is just do the FTC. My picture, I could draw it. You know, it's got a slant asymptote and it's related to a rational. Here's the deal, though. I'm just going to do it. And how do I do that? I got to simplify the integrand. And as I do that, I want to point out what I'm really doing. I'm doing x minus 1 over x squared. I'll write that down for you. If you do that in your head, that's fine. I'm not saying you can't do it in your head. X squared minus 1 plus 1 over x squared. Well, I'm going to write that down for you now. Minus 2 to minus 1. We're not trying to trick you, by the way. This integral is defined at an interval. The only place it's not defined is at 0, and we're nowhere near 0. So what do you get over here? You get x squared minus 2 plus x to the minus 2 dx. What am I going to do now? Fundamental theorem of calculus. X cubed over 3 minus 2x. Well, let's see, what do you get there? You have to add 1 to the exponent, right? Which would be minus 1. And divide by minus 1, what do you get? You get minus sign. So let's put the sign down, the limits down, minus 2 to minus 1. And let's go for it. And what do you get? Minus 1/3. I'm doing the upper limit, plus 2. And then it's going to be plus 1 now. Minus, I'm just evaluating some simple numbers. This is going to give me minus 8/3. And it's going to give me plus 4. And then what do you get over there? You get plus 1/2. Yeah, I know it's trouble. Let's keep going. Minus 1/3 plus 3 plus 8/3 minus 4 minus 1/2. Again, the way I do arithmetic, really, they may look different, but it's got to be the same outcome in the end. 3 minus 4 is minus 1. And then you get minus 1/2. And then, you know, minus 1/3 and plus 8/3 is going to be 7/3, right? What's common denominator there? 6. Let's see if we can do that. Minus 6, minus 3, plus 7. Let me just go for the advertisement again. I make mistakes all the time. And if I do, I'm going to fess up to it and correct it. Minus 6 minus 3 is minus 9. Minus 9 plus 7 is minus 2 over 6. And this appears to be minus 1/3. If I made a mistake, I'll correct it. I made a mistake. Someone says, how do you know you made a mistake? I just look at the answer and it says it's 5/6. And I said it's minus 1/3. Let me tell you what some students would do now. They would say, it doesn't matter. And then they go into another question and say, I'm exhausted. I don't want to do anymore. They get frustrated. I got a wrong answer. Or they say, the teacher's wrong. That teacher's answers key is really bad. I'm not going to look at his key anymore. I'm not even going to do those problems anymore. I'm so upset. And they move off it. But I got to tell you something. That's a really bad attitude to have. So what I'm going to do is I'm going to say, you know what? I probably made some really bad errors somewhere. So I'm just going to fess up, you know, tail between my legs, so to speak, and I'll try again. So it's too much work to try. Well, the alternative is when you don't try, things get really tough. Let's see if I did that multiplication right. So x times x is x squared. That looks pretty good. Then x times, you know, minus 1 over x would be minus 1 and get minus 1. Yeah, I think I did it right. So I got x squared minus 2 plus x to the minus 2. Let's put this down now. Maybe I made a mistake somewhere. So did I get the right limits? Yeah, I think I did. Let's put this down. That's my second time trying it, right? So what do you get? And someone says it's really not going to be different. You're just going to make the same mistake over and over again. You're right. Sometimes you do. In that case, what I'd say is come back later and do the problem. I increase the exponent by 1 and divide by the new exponent. This would be minus 2x And I'm going to increase the exponent by 1. So it'll be x to the minus 1, divide through by minus 1, which would make it minus that. And what's my limits of integration? Minus 2 to minus 1. And let's try again. All right, let's be more careful though. What do you get? If I put in minus 1, I get minus 1/3. I think I did okay there. Plus 2 plus, let's see, that would be 1 over minus 1, which is minus 1. Minus 1 is plus 1. That's pretty good. Minus, let's do the minus 2 now. That's going to give me minus 8/3 plus 4. And that's going to be plus 1/2 now, right? All right, I hope I don't make the same mistake twice, right? Minus 1/3 plus 3. That's not so bad. And then you could get plus 8/3 minus 4 minus 1/2. Let's keep going. I get minus 1. Let's see. Minus 1/3. I'm sorry, minus 1/3 plus 8 is 7/3. And then minus 1/2, right? Oh boy, I got to do some work here, don't I? So common denominator 6 minus 6 plus 14 minus 3. And that's going to be minus 6 minus 3 minus 9. Minus 9 and 4 is going to be 5, 6, right? I definitely got a different answer. Did I get the right answer though? Yeah. So let me tell you the tale of the story. If you make mistakes, erase your work and try again. Some people say, no, I'm just going to look for my error. You can do that too. I don't mind whatever you want to do. All right, number 5, a little more complicated because I don't know the antiderivative of that. So what I'm going to recommend you do is, again, simplify that integrand. I need to remove the absolute value from it. So I'm going to write this over here. F of x equals the absolute value of x squared minus 1. Well, I'm going to draw a picture of that. And to do a picture of that, what I do is, first thing I graph out this one over here. And what does that look like? It looks sort of like this over here. And again, you learned that in Math 100. But I didn't want to graph that. I wanted to graph the other one. What's the absolute value? So what happens? Well, this section here, which is negative, is going to flip up over here. Let me write that down for you. It's going to flip up there. Let me get my eraser out now, and I'm going to draw the picture of it. I'm going to erase this whole thing here, and I'm going to draw my picture now. And you've been doing this for some time now. And where are we going from minus 2? Up to 1. There's actually 2 curves there. So I'm going to write this down for you. It goes from minus 2 to 1. The absolute value of x squared minus 1 dx is equivalent to minus 2 to 1. Well, what's this function over here? It's just x squared minus 1 dx. I'm sorry, I said minus 1. I put down that. Plus, we start up at minus 1 and we go to 1. What's this curve? It's actually the opposite of x squared minus 1, which is 1 minus x squared dx. All right, let's keep going. And I know there's an answer over there. I'll try to get to that answer. But I got 2 integrations to do now. So what do you get over here? Let's write this down. It's going to be x cubed. I'm doing the first integration over 3 minus x, limit of integration minus 2 to minus 1 plus, this is going to be, let me put this in parentheses for you, x minus x cubed over 3, limit of integration minus 1 to 1. Let's do it one step at a time. This is going to be minus 1/3 plus 1. That's the upper limit. Minus the lower limit. I'll be careful. Minus 8/3. All right. And then plus 2. I just did this guy. Let me do the next guy. This is going to be 1 minus 1/3 minus, now I'm doing the -1. That's going to be -1 minus a minus is plus 1/3. All right. Again, the way I do arithmetic, the way I do it may be a little bit different. Our outcomes cannot be different, though. Our outcomes cannot be different. I'm going to do the integers first because they're easy for me. 1 minus 2, that's -1, plus 1 is 0, minus a minus 1 is plus 1. I'll write that down. Now I'm going to do the fractions. So what do you get? Minus 1/3 plus 8/3 is 7/3. 6/3, 5/3. Again, if I make a mistake, I'll know it by looking at the T. What do you get over here? Common denominator 3. And you can get 3 plus 5, which is 8/3. Let's hope for the best. Wow, we did it right, 8/3. All right, let's look at number 6. And number 6, a little strange looking to me. It says, find a formula for the area of the function. And it's new to me. So I gotta figure out what they're talking about over here. I'm gonna draw a picture of it. All right. And it says, why did you draw a picture of the other guys? They're too difficult. But this is a line. I can do that. It's got a y-intercept of 4. And then a slope of 2. So I'm going to say something like this over here. By the way, this is -2 over here. All right, I got that part then. It says, find the formula for the area of the function. I think I can handle it. Lower limit 0. That means just over here. And then the upper limit's over here somewhere. And they want me to get the a function, an area function over here for this. I think I've seen something like this before, right? Put this point over here. This point over here is going to be, I have no idea, x, but I do know this, x is greater than a. So what's this point going to be? X, comma, f of x. What's f of x? 2x plus 4. All right, let's kind of divide this thing out into pieces. One piece at a time. What's this piece worth? It's a rectangle, right? So what's the base of it? The base is x. And what's the height of it? Well, I got a nice picture down there. It's 4. Well, let's do the other guy. The other guy is this guy over here. I think I can do that. That's going to be 1/2. The base will be x. And what's the height going to be? This is the height of it. And that's going to be 2x plus 4 minus 4, which is just 2x. Let me simplify this. This is going to be 4x plus x squared. This is going to be the area under that curve, which is 4x plus x squared, with the understanding that the lower limit is going to be 0 and the upper limit is bigger than that. So it's going to be bigger than that 0. All right. Again, the a was equal to 0. All right. Now, someone's going to say, that's fine by me. You got an answer over there. Did we get the answer they got? We did. I commuted around. But then they did it a little bit strange way. And I'll point out what they've done over here. They've integrated. And let's go for that. All right. So what are they doing? They're going from, this is going to be the area function now. Whoops, sorry about that. This is an area function. It's a function of x. Where are we starting? We're starting at 0 and we're stopping at x. Now this may seem strange to you. I can't put x as the integrand. So I got to put a dummy variable in. So it's going to be 2t plus 4 dt. Let's do our integration. It should be simple. What do you get over here? T squared. I'm doing the antiderivative. Plus 4t. Limits integration 0 to x. What does this give us? X squared plus 4x. Minus the lower limit, which is just 0. That evaluates a 0 there. What's the answer? X squared plus 4x. Are we getting the same answer? Of course we are. It would be ridiculous to get a different answer. So that's number 6. And again, I'm learning as I'm moving along. And certainly we want to retain what we learn. And the way to do that is you practice the problems over and over again. Go next. Oh, this one looks really tough. Verify both antiderivatives are correct. So this happens sometimes. So a lot of times what happens to people, they look at these things and they say, how can I verify that? Well, to verify it, what you really have to do is you've got to differentiate both of those. So let me write this down for you. So you need to differentiate 1 over 1 minus x plus c1. And by the way, sometimes I have to do this when I look at a student's work, I say, is their antiderivative correct? And it's happened to me before. I got to go through the work. Here's the deal though. If it's correct, these antiderivatives differ by a constant. But I want to verify that these both give me back what I expect to get, which is this. I expect to get this back. That's the integrand, right? I'm expecting to get it back. Now someone could say, I don't believe that's true. Well, I got to do it one step at a time. So let's do this one first. I'm going to verify this. I want to verify it. So really what I'm doing d dx, and I want to verify that 1 minus x to the minus 1 plus c1 is what they said it is. Well, let's go through it, see what happens. What do you get? Minus 1 minus x to the minus 2, chain rule times minus 1 plus 0. Let's simplify this. What do you get? A positive number over 1 minus x squared. Did we verify it? Yes, this is verified. Right there. Let's verify this one. Whoops, of x over 1 minus x plus c2. That's student number 2, by the way. Let's take a look at this. A little more complicated, isn't it? So I got to square the bottom. Bring the bottom to the top. The root of the top is 1 minus the top times the derivative of the bottom, which is minus 1. The derivative of c is 0. Wow, this doesn't look like it's going to work out, does it? What's the bottom going to be? 1 minus x squared. What do you get on top? 1 minus x plus x, which is 1. Does it verify? It does. This also is verified. We did it over there. I want to point out that these things differ by a constant. Let me go through that with you. So 1 over 1 minus x plus c1, right? They differ by a constant, minus, let's write this down, x over 1 minus x plus c2. My claim over here is that these are going to differ by a constant. Let's take a look. Let's see what we got over here. So what'd you get if you did that? You would get 1 minus x. I'm combining these two terms together over 1 minus x plus c1 minus c2. And what do you get over here? Well, on the domain of the problem, this is going to be numerically 1 on the domain of the problem. What's the domain of the problem? All real numbers except 1. So on the domain of the problem, this would equal 1. So what do you get? C1 minus C2. Is that a constant? It is. 1's constant, C1's constant, and C2 is constant. So they differ by constant, all right? Pretty simple. All right. So the bottom line is we did the differentiation. We showed it's true. And that wasn't bad. All right. We did okay. All right. Let's see if there's another question. I don't think there is, but maybe, oh, there is. There's more. This is killing me. Find a formula. Well, I'm going to do it. I'm getting better at this now. What's that going to be? Minus e to the minus t. That's its antiderivative plus a constant. But this is an integral limit, so I'm not going to put the constant in. That's 3x, and this is 9x plus 2. Let me write that down. Minus e to the minus 9x minus 2 minus a minus, which would be plus e to the minus 3x. I'm going to write a little bit differently. Don't feel like you have to. Good the key. See how we did? And we did fine. We got the right answer. All right, a little more difficult. And what I mean by difficult, the reading of it can be tough. It just says, can you follow the steps and write in plain English what's happening over here? So, I know it's difficult, but the bottom line is let's just talk through the steps. All right. So what are they doing over here? Looking at this guy over here, I want to point out they are taking a derivative. And what it appears they're doing over here is they're doing the definition of the derivative. The limit as h goes to 0, this would be h. All right. Then what do? It's going to be the x plus h. I think you remember me doing this before. Minus the x. I want to point out what we've done before. If you remember that definition, and I'm hoping you do. Let me write that down for you. So limit h goes to 0, h f of x plus h minus f of x. All right, I think I understand that. That's all they did. All right. So this is like some kind of function over here. They just simply said, oh, it's a function of x. It is. I just don't know what the function is. They just did, oh, x plus h minus x. That's all they've done. All right. Now, next thing, it looks strange to me. I wonder how they got that. All right. So I'm gonna draw a picture of this. Right. I gotta draw a picture of it. So we're going from a to x plus h. That's this guy over here. And the other one goes from a until x. And I'm going to say, if h is, greater than a 0 or so, doesn't really have to be, but I'm going to say I'm over here somewhere. All right, so this is x over here. So they're talking about this area. So what's that going to be? From x to x plus h. And that's written right over here. That's what they're doing. Now let me point out they're doing subtracting it. So it's this long guy, take away this guy over here. What are you going to get? X to x plus h. All right. Now visualize that h is greater than 0. It doesn't have to be. H just can't be 0. All right. So then they go somewhere over here. They say that, oh, this looks really tough over here. They got this x star business over here. So what I'm going to do is I'm going to try to visualize what they're talking about over here. So they got this over here. Whoops, let me get to my black ink. Again, I'm trying to read and understand what I'm reading. I know they're going between x and x plus h. And I know this represents some kind of area over here. I hope you realize the h is going towards 0, so that those things are getting really close together. So what they're saying is that there's some x star in the middle here between x and x plus h. Well, that seems reasonable to me, right? That seems reasonable. And then they go on to say that, well, if that's true, there would be an area there for me to compute. There would be an area there. And what's that area going to be? F of x star times this delta x. And what's a delta x? The delta x really just is h. That's all it is. But then this is the delta x, and the delta x is just the h. So they write that down. They say the function evaluated there, and then they write down that delta x is just h. So what do you get over here? Well, look at it. You got h's are canceling off. So what do you get? The limit, I'll write this over here, as h goes to 0 of f of x star. What would that be? X star. But then the question comes is, what's x star if h is going towards 0? I hope you realize that x star would have to be x. And why is it goes to zeros? It's getting squeezed in between x and x. So it's got to be x. All right. So I'm sorry. I didn't mean to say it. I meant f of. Sorry about that. F of x. That's all it is. All right. Remarkable. All right. A remarkable result. Now someone can say remarkable. Do I need to remember that? No, you need to be able to follow. That's what you want to do when you're reading a book. Can you follow what they say? Not memorize, but follow what they say. All right. As you start to follow, you'll eventually become a lead and you'll get it there. All right. A little more difficult. Let me just talk through it. at least in the English steps of it, a derivative of x is given by this over here. I'm sorry, the antiderivative of that given by that over there. And we know that all antiderivatives differ by a constant g of x. Yeah, we talked about that before, example prior. Let g of x be one of these antiderivatives. Not a bad idea to put down. So what did I do over there? All I said was that it's one of the antiderivatives. I'm not saying it is the antiderivative, but it's one of the derivatives. So I'm going to say this guy's antiderivative, which I'm going to say let g of x be one of them, would differ by a constant. That's all we're saying. Right? We're saying it differ by a constant. Then what do? We take a look at the limits and we say a to a. Now I hope you realize if I took an integral and it went from a to a of any function f of t, provided it's defined at a, whoops, dt would have to be 0. Now that is reasonable. So what do they get? They got minus g of a c. Right, you see that? All right, then they got b. All right, let's see if we can write that down. And what do they say? They say that there's another guy here, and this would be, well, that seems reasonable. We got, let's see, b. Well, let's write that down. A to b, f of t, dt would be, I know what this looks like. This looks like what? It looks like g of b minus g of a. Would that be agreed? Well, I guess I could rewrite it. This would be a to b f of t. I'm just reading, see if I can understand what that line says. Minus g of b would equal minus g of a. I'm seeing that line now. What do they do now? Let me just see if I did what they said to do. Yeah, we're back in the loop again. We're back over here. Let me just make sure I got this. And oh, I'm sorry. I probably shouldn't have done this over here, but it's okay. I did that. What they did was they used the original one and wrote that. Instead of using x, they used b over here, and that's fine. And that's going to be a constant, which is c. All right. And then they wrote it over here. I went a little bit backwards on it, but that's okay. I understood what they were doing. Let me go to, ooh, there's no more. Okay, let me point this out. We're not asking to memorize. We're asking you to follow. Is following difficult? It is. But at some point, when you follow and you follow enough times, you get to start to lead. And that's what our goal is here. We want you to start to lead. All right. What does lead mean? That you start to thrive in your career choice. All right. So let's take a look. And I think that's done with that section. Let me stop the share. And again, if you have any concerns about what we're bringing presented to you, please come by Darwin office hours, and I'll be more than happy to help you.